Hi, everyone. So here I'm going to continue showing you on the multiple regression work that we're doing and show another correlation of the categorical variables. So we can do this via cross tabulation. So we kind of saw something like that before, but here I'm going to use the CrossTable function of the G models package is already installed. So I'm just going to run the CrossTable function, and that's between COPD severity and diabetes. So these are two categorical variables in the data. Diabetes is just 1 or 0 if they have it or they don't have it. And COPD severity, which is the pulmonary disease severity, is, I think, for 4 different levels. So 0 is low, 1 is mild, and so on. So if we run that, we see the tabulation. And how to read this, let's focus on these numbers here. So diabetes is 0 and 1, and COPD severity is mild, moderate, severe, very severe. So 19 people that have mild COPD severity do not have diabetes, but 4 of them do have diabetes. And the total here is 23. And you can go around and look at the numbers to see any potential correlation. For example, do more people with very severe COPD have diabetes? Well, here's the ratio is 7 to 1. So actually this ratio is smaller, and you can do the specific calculations of ratios, but this ratio 7 to 1 seems smaller, or let's say larger, depending how you order it, than, well, actually not. Doesn't seem that much larger at all. In fact, I don't see a correlation between COPD severity and diabetes here, which is interesting, but there could be, right? So this is the indication, and let's take a look of that in the regression model. So let's remember, we may have done this regression model before in R, and I'm going to put here for notes the linear regression equation. And the multiple regression is just the addition of predictors into the linear model. And let's focus on a model that is going to explain walking distance, because we have this in the data. So we're going to build a model to explain walking distance with the following predictor variables here. And note the importance that the outcome or dependent variable is continuous. That's why we're selecting, we have to have an outcome variable that is continuous, okay, for linear regression. So let's check that. So one of the things we can do is actually begin little by little. So just build one factor model, or one predictor model. So this is gender. We're going to see how gender predicts or helps determine walking distance. And gender is a factor variable. So let's just run this way and see what happens. We run it. And actually, gender was classified as a, before, as a integer, but then we changed it to factor, right? Yes, factor. So it's already shown as factor here. And we can see that because it says gender 1. If it was integer, this 1 wouldn't appear. So that means, as you may remember from previous lectures, that gender 1 is the 1 in relation to the 0. So gender 1 is male. No, actually, probably gender male is 0 and 1 is female. So there is an increase of 30 walking distance compare for gender 1 compared to gender 0. So for female compared to male. I'm sorry, for male compared to female. So the male has a longer walking distance than the woman by 30 points of this variable. But it's not significant. If we look at the p-value, it's not significant, 0.17. Another variable that we have to consider is this R squared variable. So there are two usually provided, multiple R squared and adjusted R squared. And the R squared is really important because it is the amount of variation in the outcome variable explained by the model. So this is really low. and it's in terms of percentage. So this is 1%. 1% is explained by this model. So this model is not very good, and this one variable is not very, it's not significantly correlated with walking distance. But you can check little by little, because you don't want to, sometimes you don't want to add all the variables at once that you don't know. So you can, and I'm just wanted to show you here as well how we can do these one predictor models. And we, for example, let's look into the impact of, so this is the predictor variable, the long function, into the walking distance variable. And created the model there, and this is a very low p-value. It says 3 stars, very significant. Here's the scientific notation, so this means there's a lot of zeros. That's why it's not even showing it turned to scientific notation. This is the estimate, so this is the coefficient. It's a positive association, so the more long function, the more walking distance, which makes sense. An increase in FEV1 leads to an increase in walking distance. A unit increase in FEV1 leads to an increase in walking distance of 74.11. And this model, look how this R squared went up. So this is 22%. Well, adjusted is supposed to be a little better R squared measure, so use adjusted R square, but they should be similar. So adjusted R squared is 0.21, which means this model here, this model with one predictor variable, explains 21% of the variation in walking distance. So it's not great, but often multiple regression models are actually not that high in R squared. And we can use this confidence interval functions as well to check confidence interval. I should put it here. And we run these 2 of them, and it gives you the confidence interval of those measures. Okay, so for the FEV1, that came out 74. Well, but if you want to be 95% confident, it's between 46 and 102. So there's a lot of variation there. Same with gender as well. But why don't we build the actual multiple regression model then? Okay, and we'll do that in the next video.